In this video, I want to have a look at limits. So when we're talking about limits, we're looking at the behavior of a function as that function approaches a particular value of x. So if we wanted to know the value of a function f of x as x is approaching a, so a is just some number or value, then we'd write it like this. So we'd write the limit as x approaches a of f of x is equal to L. So L will be the value that that function is getting closer and closer to. So our first one says we've got f of x equals x plus 2. So we know from that that y-intercept is going to be 2. So let's consider the limit as x approaches 0 of that function x plus 2. So as our x values get closer and closer to 0, our function, doesn't matter which way we come from it, our function is going to get closer and closer to that value of 2. If we have a look at our next one, we've got f of x equals x squared minus 4. So we know that our roots are going to be minus 2 and 2. So let's, for this one, maybe have a look at the limit as x approaches minus 2 of that function x squared minus 4. So we're having a look at what happens, the value of that function as we approach negative 2. So as we get closer and closer to minus 2, the value of that function is going to get closer and closer to that value of 0. And our last one here, we haven't been told what this function is. But what's interesting about it is it's concave down parabola, but it has this discontinuity here. It has this like infinitesimally small hole where that function isn't defined. So I want to see what happens there. So we're going to write the limit as x approaches, well, it's got an x value of 2, so we'll write as x approaches 2, of that function f of x is equal to. So even though this function isn't defined at that point, it doesn't have a value when x is equal to 2, we can still have a look at what happens to the function as we get infinitesimally close to it. So as we approach the x value of 2 from both directions, we're going to get closer and closer to that value of minus 1. So even though we never actually reach it because it's not defined at that point, the limit as x approaches 2 of that function is minus 1. So we want to have a look at a few examples of how we can find limits without our graphs drawn. So in this one, we've got the limit as x approaches 3 of x squared. So for this one, all we're going to do is substitute in that value. So we'll have 3 squared, which is equal to 9. And that's actually going to have the exact value of 9 because a function x squared is defined at all points. So for our second example, we've got the limit as x approaches 5 of 1 over x plus 2. So again, we'll substitute in that value of x that we're approaching, and we'll have 1 over 5 plus 2. So we have 1/7. So again, no problems there. Our last example is this one here. It says the limit as x approaches 1 of x squared minus 1 over x minus 1. Now if we substitute into this one, we'll put that x equals 1 in there. We'd have 1 squared minus 1 over 1 minus 1, which would end up giving us 0 over 0. And we know that we can't divide by 0, so that doesn't make any sense right now. What this function is telling us, if we get rid of this because it doesn't work, what this function is telling us is that x minus 1 on the bottom means that that function isn't defined where x equals 1. So because it's not defined, we can't just substitute in like we did the other ones because that function doesn't have a value at that point. What we're going to do instead is factorize and then simplify that function down. So we'll leave our limit there. So the limit as x approaches 1. That numerator we can factorize because that's the difference of 2 squares. So we can factorize that to x plus 1, x minus 1. And we've still got it over that same denominator of x minus 1. So now we can simplify that down. So we've still got the limit as x approaches 1. And we've got an x minus 1 on the top and the bottom, so that will simplify down just to x plus 1. Now that we've got it simplified, we can substitute in. So that would become 1 plus 1, which would give us a limit of 2. So just to summarize all of that, the limit of a function is the value that that function approaches. We can find the limit if it's defined at that point. We can find it just by substituting into the function. If we ending up getting a denominator of 0, though, we're going to have to factorize and simplify our function down before we can substitute. So that is an introduction to limits.